So linear approximations. Linear approximations is used to approximate, of course, we want to approximate a value that we cannot get the actual value without using calculator. So we can approximate it. For example, we want to approximate 2.01 squared. So we know that the value is about 2 squared because we know 2 squared is equals to 4. But we cannot get the actual value of 2.01 squared unless you are very good in your math. So let's look at this graph that we have here. Fx is equals to x squared. So this is a graph for a function of x squared. So if you want to approximate the value of 2.01 squared, we can just use by using the concept of tangent line. So let's say we want to approximate at about 2.01 squared somewhere here. So let's say this is 2.01. Therefore, we want to know what is the value of 2.01 squared. But without using calculator, so we can use the equation of tangent line. And since we know that the value of 2 squared, so let's zoom this graph. So let's say 2.0 is very close to 2.01 here. This is our 2.0. And from here, if we draw a tangent line at about x is equals to 2. Okay, so the blue line is our tangent line. So from here, we know that this is our f2. So our f2 or 2 squared, which is equals to 4. So from the tangent line, so we know that y minus y naught equals to m x minus x naught. So for example here, so we assume that our x naught and y naught is 2. So let's assume that our x naught is equals to 2. So x naught is equals to 2. And if I can rearrange this, so we'll have y is equals to y naught plus m x minus x naught. And let's rewrite this in the form of fx. So we know that y is also equals to fx. And y naught will be f x naught plus, and m is the gradient, or the gradient also can be written down as f prime of x naught and x minus x naught. So in this problem, we want to find fx, or our x here is equals to 2.01. Therefore, we want to approximate 2.01 squared is equals to fx naught, which is 2 squared, since our fx is equals to x squared. Okay, and then plus f prime x naught. So yes, before that we have to find our f prime x, which is equals to 2x. So f prime x naught, which is 2, and our x naught is equals to 2, multiplied by our x is equals to 2.01 minus x naught, which is 2. Okay, so let me clarify this. 2.01 is our x, and x naught is equals to 2. Okay, x equals to 2.01 and x naught is equals to 2. So let's just substitute this value, x into this and x naught into our function. Therefore, so actually we'll have an approximate solution for 2.01 squared is equals to 4 plus 4 multiplied by 0.01, and this will be approximate to 4 plus 0.04, and if we sum this up, so we'll have 4.04. So this is the approximation. Now let's check our actual value for 2.01 squared by using the calculator. Or if you can check by your own from your calculator, so we'll have 2.01 squared when you press on your calculator, so we'll have 4.0401. So as you can see, our actual solution is about the same as our approximation. So this is the concept of linear approximation. Now let's look at another example. Now let's say we want to approximate this value, which is 4.003 to the power of 5. And by using the formula that we have derived earlier, which is, so we can just use this formula again. So if we write down is fx approximately as f of x naught plus f prime of x naught multiplied by x minus x naught. So from here we know that our fx is equals to x to the power of 5. So we have to select our x naught and the nearest value that we can approximate here, so we'll use x naught is equals to 4, and our x will be the value of our problems here, which is 4.003. Since we want to use this formula, so we'll have to find our f prime. So our f prime x is equals to 5x to the power of 4. And then let's just plug in into our formula. So we want to approximate the value of 4.003 power of 5. So fx naught, which is 4 to the power of 5, plus f prime x naught, 4 to the power of 4, multiplied by x minus x naught, which is 4.003 minus 4. So 4 to the power of 5, we know that this is 1024 plus 5 multiplied by 4 to the power of 4, which is 256, multiplied by 4.003 minus 4, and that will be 0.003. And if we calculate this, so we'll have 1280 multiplied by 0.003, and the final answer is 1027.84. And if you can check with your calculator, 4.003 to the power of 5 is about 1027.84576,432, and so on. So I hope from this topic you can use the differential to estimate the value of a given functions. For example, in these two cases here, so you can use the linear approximations, and I hope you can also understand of how did we get the formula of the linear approximation.